All right. So looking at the submissions, most of you have turned in Project 4. Not very many of you have turned in Project 5. And I would like us to be done with Project 6 by the end of this week, since this week ends the course. So I would say that if you haven't begun 5, you're definitely behind. If you're in the midst of 5, then now's the time to put in a little bit of extra oomph. And of course, I want to help you bring that to completion. I wanted to go ahead and spend a little bit of time for those few of you who have completed Project 5 to talk about Project 6. It is in 2 parts. I'm going to cut you a little slack, and I'll make the second part like extra credit. So you only have to do the first part. But I'll go ahead and talk about both parts. Yes?
Project 5 was listed as 10 points.
Ignore the... Oh, I'll change that to 100. It had originally been an assignment, and it's difficult enough that I thought it should be able to sit on the shelf with the other projects, rather than being relegated to the book bag of assignments, so to speak. So, Project 6. Let me go ahead and introduce that. And try that again. All right, so if my window is small enough, oh, it doesn't appear on, I thought that would all appear on one line. All right, that's all right. All right. Here's the situation. I, of course, came of age in the golden age of role-playing games, which then was primarily Dungeons and Dragons. And in fact, I know many of you are fans of Stranger Things. They're the primary kids, and then what is the boyfriend? What's his name? The slightly older kid. There's like the daughter. Let me see. Of one of the primary characters has an older sister, right?
Right,
Nancy and her boyfriend. That's my age. I think they were. What are they, like seniors in '84?
Yeah.
I was a senior in '84, so that's literally my age. So I grew up on Stranger Things. Yeah, I remember that, and not the undergroundy, upside down stuff, but the.
Depends on how many mushrooms were.
Like, have you seen when they did way prior to season 3, when they did kind of this fake mall promo?
Yeah.
Anyone seen that YouTube video? Wow,
Right.
the hours I spent in Walden Books in the mall.
It's owned by Russians.
Anyway, I digress. Project 6. So of course, in recent years, wanted to rekindle that love of role-playing games with the friends that I grew up with, and they're of course spread all across the United States. So need an online version of being able to do that. And there's this tool online, Roll20, that allows you to do virtual tabletop gaming. And let me see what comes. It's been actually took a bit of a break from it, so I'm not sure what I'm seeing here. All right. And so we play on this here. And this is the genesis of the project, which is the map that you're looking at. And the map back in the day, there were a lot of pre-generated modules you could buy. Let's see, AD&D 1E module. Yeah, so you get these things you could buy. They'd be little canned adventures you could run. And I've got a bunch of them from that period of time. And the maps look some variant like this here. This one's definitely a little bit cluttered and noisy, but you get the general idea that, let's see if I'm able to actually zoom in on that. So you can see that what it is essentially is was originally graph paper, and then these dungeons were drawn onto the graph paper. I know that a lot of you are already familiar with all this, but for the odd person who hasn't done tabletop role-playing. So what I want to do is I want to be able to get this kind of stuff, of which I have a lot of, online. And the question is, how can I most quickly go from what I'm looking at here to this kind of thing right here, where it translates to this look? And specifically speaking of the background, where you have these floor tiles and the walls and the hallways and the doors, all this stuff's extra. And so there are actually generators out there that can do this, or that you can draw this, but it's really a long and arduous process, and I wanted to try and figure out what is going to be the quickest workflow for me to go for those graph paper dungeons to this. And so what I came up with was, I'm going to quit out of this because this is taxing my processor. Well, let's see. And I should have done this ahead of time. So let me start with the final step. All right, so this is actually now this is a little bit hard to see, so I'm going to shrink it. No, I don't know what impact this is going to have on that little broadcast thing. Broadcast what? Didn't go up at all? Oh no. All right, I'll have to troubleshoot that. All right, you can see what you can see here, if you kind of blur your eyes a little bit, is that the hash marks is solid earth, and then rooms. This constitutes the rooms with the periods, and then this would be a door here, hall down here. All right, you kind of see that, and you kind of see that these are walls here. So what I can do is I can actually fairly easily go from this to what you saw online. And because what I can do is I can basically read through this row by row, and if I see a hash mark, that's just solid earth, right? If I see this pipe, then I need a wall. and then these would be those square tiles, these dots. And they're all spread out. In this case, they're all spread out so that I can put walls around things. So you could see if I literally had that, then I could put walls all the way around that. Right? That's why this is kind of extra spread out. Now I will say up front that the project doesn't have anything to do with walls, because that just adds an extra layer of complexity. So really, what would this look like without walls? And I wouldn't need it to be quite as opened up like that. Would be this, and this is much simpler. So this is an open space in a room. Here's a hall going down. We've got some diagonal walls here, done with the slashes. And so if you ignore the fact that you need doors or walls, then this works fine. So the question is, how can and then I can easily write an algorithm that just goes through this row by row, and if I have square graphics, all I have to do is pull the correct graphic and drop it in, and then I just need an image manipulation tool to kind of sew them all together, right? And that tool does exist. So I could even write a shell script to do that. I don't even know that I need Python to do that. But the question is then, how do I draw this that we're looking at? And again, keep in mind that I've got all this on paper. And what I want to do, let's look at it from a different perspective. If you got a piece of paper with an essay on it and you needed to transcribe the essay, you want to stare at the essay, and assuming you're a touch typist, you just want to be reading off the essay, right, and doing that. So I need that kind of workflow where I'm just staring at that map and I'm actually drawing it. And so what I came up with was, let me find, this is probably going to be too, alright, this is an older version that doesn't automatically. Let's create about 15. Alright, so that's 10 by 15. This is all solid earth, so that would be my starting file. Now what I've done is I've mapped H, J, K, and L, so just my Vim, up, down, left, right. And you'll also note that the characters are twice as high as they are wide, so that box that's moving around is actually 2 characters. And then I use spacebar in the bottom, that's showing my current row and column. And then when it says current, that's for lack of a better term, the paintbrush that I currently have, which in this case is earth. If I hit, my spacebar toggles between different brushes, and there are just 4 of them. So there's earth, this is represented as open space, this is a diagonal running from upper right to bottom left, and that's diagonal going from upper left to bottom right. So those are the only 4 things. So what I can do is, if I do that, the way that I draw is my movement remains the same for keystrokes, H, J, K, and L, but I hold down Shift, and if I hold down Shift, then I'm drawing. So I can hold down Shift, and this actually works pretty good. I can go for a good, I don't know, 3 minutes between looking over at my screen where I'm just tracing, okay, the hall goes down 5, and then it opens up to a 2x2 room, and then in the bottom there it goes off, right? You can actually read that map and start drawing these things, and it gets a little more complex when you have the diagonal walls. And the diagonal walls don't look great here. Let let's see if I can. And then I think that I'll create an extra wide diagonal going up to the right. But when I'm done, I can hit S for save, or in the middle. It's not necessarily when I'm done. And then I can type an uppercase Q to quit. And that creates that. Then I run it through the script that generates the image. The script for generating the image. I actually wrote this program in both C++ and Python. This is my C++ version. And I don't remember where the Python version is. I'll dig that up. Let me see here. If I do, I don't have the workflow handy here. So I'm not going to go through the rest of, I'm not going to take what we just looked at and convert that to a graphic, but I have a different example attached to the project that I'll show you. So let me come back to the project. There's this dungeonpieces.tar file. Let me go ahead and look at that. Tar. Alright, creates this directory in here. There are some examples. So everything now so let me talk about what the two parts of the project are. The first part is the editor. So that editor thing we were just looking at, that's part one. Part two is the part I'm showing you now, which is taking the file and turning it into a finished graphic. And this tarball is all relevant to part two. So here's my, what is the, how do I want to say this? Let's look at Earth. So there are two directories here. There's Earth and Floor. Actually, let me look at Floor first. These contain the graphics, and what Floor contains are 40 random tiles. And when you're generating the floor of the dungeon, what you do is just randomly choose these, right? You don't want to choose the same one, then it obviously looks like the same thing. If you randomly choose these, then it kind of looks like what you saw with that online thing. What Floor is, or what Earth is are these templates. And what you do is, if you need a diagonal, you randomly choose one of these floor tiles, and then you use the graphic software to lay this on top. And what it does is it basically, the stuff you see in white here is transparent, so you end up seeing the original floor tile here, and then this is black, which would constitute solid Earth. So coming back to these files then, so this that I have here can actually be run as a bash script. This is an example of a file you would have created with the editor. And what you'd do is you'd create a temporary directory. Again, this is all hard-coded in this script. You'd make it a little more dynamic. And let me see, where is this going? Alright, so next is, let me pause for a moment and talk about this. The way to create the final map graphic, you use a set of tools referred to as ImageMagick. And we haven't done anything with ImageMagick in here, have we? Okay. ImageMagick is not a tool, it is a suite of tools, and they're all command line tools. So for people who are doing shell scripting and Python and stuff like that, ImageMagick is the bomb if you have to do anything with images. You can do anything with this tool set. It is incredibly useful. And they're all just separate command line tools. We're using two of them. One is composite. Composite is literally laying multiple images on top of each other. And there are a ton of options. We need very few of them. So here, what's being done is, if you look at, say, these two squares, you know that that's going to be solid earth. The question is, well, what do you do with this diagonal? Well, if you think about it, this solid earth is going to continue to the upper right. You see how that would be solid earth? I guess I'll draw a quick picture. This is solid earth. And I have this diagonal. What else is solid earth? This has to be solid earth, right? And then this would be floor. And then the same for that other slash. If I have solid earth right, if I have solid earth right here, then this has to be solid earth. So by looking at what's to the left and to the right of the slash, you can determine where the solid earth needs to be. And once you know where the solid earth is, then you know which of those four funky diagonal templates you pick. And so that would have been done through a little bit of a couple if statements. Here it's obviously hard-coded. So this is for the lower right floor, that template. This is for the upper left floor, this template. And then these are two random tiles that are selected, and then this is the output image. Then you have to build this example file list.txt. What is that precisely? Let's look up here. Actually, let me jump down a little bit. Montage, so composite overlays multiple graphics. Montage is an ImageMagick tool that lets you take a whole bunch of different images and tile them together into a single image. And you give it a file list, and then you say you want a tile, and you just give it the dimensions of the tiling you want, and then this is the resolution of those images, which I've provided for you. So really, this line you would pick wholesale. You wouldn't need to make any changes to this line at all. All you have to basically do is build this list here, and you need to be able to provide the number of columns and number of rows. The example, so given that that's how this tool works, what is the best way to convert this into something that that tool can use? And the answer is we've got 4 columns by 5 rows for a total of 20 graphics. The easiest thing to do is to create a file with 20 file names in it, each of an individual graphic. So we would have earth, 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 dot ping, earth, earth, 6 earths, and then one of the random floor tiles. Another earth, that diagonal that we generated on line 14, that diagonal we generated on line 15, a couple more earths, another floor tile, and then the rest are earths. So if I look at example file list.txt, that is exactly, whoops, that's not it. One, two, three, 4, 5, 6 earths, and then a floor. All right, there's the 4, 5, 6 earths, and then the floor tile. 2 more earths, the diagonals that I generated. 2 more earths, another random tile. So you just have to build this file list, and then you run it through that montage command. And then at the end, don't forget to clean up your mess, which in addition to the temp directory would also be this file. In my implementation, I actually put this file inside of the temp directory, so it would get removed when I remove the temp directory. Let me go ahead and comment this out so we can see what the script does with it, what it creates in the temp directory. All right, so there's the temp directory it created and would normally, and it also created, it's 832, so it did create this JPEG. Let me look at temp. We can see there are the two images we generated. So again, that composite image magic command literally took two separate graphic images and married them together. So earth, 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 4 earths, 2 more earths, a random tile, another 2 earths, the diagonal thing we created, another diagonal thing we created, another earth, random tile, and the rest are earths. So that's what part 2 is. Part 2 is all this graphic stuff, taking that file that you create and creating the graphics. So as I said, I'll leave that as extra credit. What about the part that I'm asking you to do as the deliverable? Primary deliverable for the project, part 1, that is the editor. Let's talk about that a little bit. All right, Python. That editor is written in curses. What curses is God, have I talked about curses at all in here? All right. Curses is just a text-based interface library. It's a C library. So if I type man curses, it probably you can see it's in section 3, which is library function calls. You can see it's got a pound include. This is all C code that you would write normally with curses. Actually, my first programming job was C on Unix using curses. What do you create with curses? Those text-based graphical interfaces like the editor that I just showed. We had to do forms for inventory applications. Whoops. Oh, let me get out of here. Nope, I don't want that. All right. So this file's titled The Old Days. We don't have to do this now, but I wanted to provide this information to explain what's happening. You know how when you type and you see the characters you're typing? Where's an example of somewhere where I'm in a terminal window, I'm typing and I don't see the characters I'm typing? Password. Okay. Whether or not you see those characters, that's a function of the terminal. Now right now that terminal is just a piece of software, but that piece of software is mimicking the same terminal hardware that I used in 1991. All right. So interestingly enough, despite the 21st century, we've got these nice windows for terminals. They're emulating really old technology. How is it that when I tell this terminal to clear the screen that it actually erases all the text? How is it when I run that painter program I get those lines drawn? All of these are commands that are going to the terminal. Now here's the interesting question. If I do a cout statement and it prints my name, how is it that the terminal is not interpreting that as some special terminal code? Or to turn it around another way, how is it that I tell the terminal I have a special code and I want it to clear the screen? right? And the answer is it's all in the timing. If you send a sequence of characters, of special characters that a terminal is looking for very quickly, the terminal will not spit it blindly to the screen. It'll grab those characters and do some sort of predefined action. And there are different terminals. There are X terminals. There's VT100, VT230. I don't remember all the different terminals. There were just bunches of literal hardware terminals. Each had hard-coded into them different codes that they understood, and some had families of codes that were similar. So when you do your term variable, what you're doing is you're telling the software what sequence of codes to send. So if my term is X term, I'm going to send a particular set of keystrokes to clear the screen, and if it's VT100, then it's going to be a different set of keystrokes to clear the screen. All right? So that's what your term is doing. What are those keystrokes? It is usually the escape character followed by some sequence of 2 to 4 characters. So if you see an escape followed by 2 to 4 characters in very quick succession, the terminal will not spit that to the screen. It will grab those characters and try to interpret them and do some sort of behavior, like clear the screen, move the cursor to a different part of the screen, change the color, right? All of that's how that works. It's all in the sequence of characters that are sent and the speed with which they're sent. And so that's why we can use Vim and use escape successfully, is that we're not cramming keystrokes super quickly, causing the terminal to interpret it. Let's see. Yeah, it's not showing it. Sometimes you can see, depending on the machine you're on, you can see that this PS1 is this prompt right here. Sometimes you see escape and some control characters in there, and that's because those are actual commands to the terminal. All right, so that's a lot of preamble for the good old days. This is obviously Python, not C. You import curses. That's a library that the module you'd import for Python. So in the curses module, I have an init screen that is doing all the initialization to set up your terminal window for dealing with curses commands. Start color. In the old days, not all terminals had color, so you had to explicitly start color. Turn off buffering. So we know from 111, you ask the user for their name. Your program that you wrote does not get the name until the enter key is hit. Okay, that's buffered input. This turns off buffering, which means every keystroke you hit immediately goes to the application. No echo. This is the password thing. If you turn off echoing, then your keystrokes are certainly going to the program, but you're not seeing them on the screen. And why would you want that other than the password? Well, you saw that with the editor, right? I was typing H's, J's, K's, and L's to move that cursor around. Clearly, you were not seeing the H's, the J's, the K's, and the L's because echoing had been turned off. Keypad, usually using the arrows is why you want the keypad on. And then you do your thing, and when you're done, you do end window. And then here's another odd one, is sometimes you want the cursor to be invisible. That was the case in that little editor program I showed you because the quote cursor you saw was what I had created. You weren't seeing this cursor that you're seeing right now. So these are various commands you do. The problem with this in general is if you have a bug in your program or it's some exception and you bail out of the program, I assume you've all at one point or another been in some situation where you break out of some sort of text-based program prematurely and then your cursor's all screwed up. Either you don't see any keystrokes or you hit enter and the prompt just moves sideways. It doesn't go to the next line. That is a symptom of some of these things being set and not being reset when you exited out of whatever program you were in. Okay? So, Python has come up with an amazingly clever way of handling that. And let's see, I don't want to type all this in. Let me grab. And here's the solution that Python came up, which is really, really wonderful. Is if you look down here at the very bottom, in the curses module, there's something called wrapper. And what you give wrapper is a function to run. And what it will do is it will get everything initialized, and then it will call this function. If anything happens in this function, it crashes, it throws an exception, then it falls back into the wrapper, and the wrapper cleans up your terminal and then exits out gracefully, so you'll never get in that situation where your terminal's all screwed up. Let me talk just, what did I not get for this? Oh, right here. When you initialize curses, this init screen, it gives you back this variable here, which obviously I could have named this variable anything. By convention, it's always called the standard screen. This is a window in which you can issue curses commands. It is literally this text terminal, this entire text terminal. So standard screen is kind of the bottom layer of everything. So this wrapper function you provide, this wrapper will, the function you provide to the wrapper will get that standard screen and will pass it as an argument to your function. So that's what this is. I go ahead and I make the cursor invisible. That should probably be, I'm guessing that would be false. That's what it would be expecting in Python. And what this is saying is to my standard screen, which again is this terminal window, I want to add a string, 5 down, 10 across, and right at that point, wherever that is, I guess this would be 5 down, 10 across would be somewhere in here. It would say, hi there folks. So right there is where it would put that string. You can create windows. Now this is for us to work with interfaces the way we're accustomed to. We're accustomed to having windows that you overlay on each other. Curses just deals with one screen, your terminal screen. So this is like a convenience tool. What it will do is it will create semantically another window. There's no actual physical window being created. It's just our understanding of another window sitting on top of standard screen, which is going to be 10 characters high, 10 characters wide, and the upper left-hand corner is going to be at position 610. So it should be exactly one line down, starting basically at the H. One line below where that prints out. And it'll return something, inner window. Now I can interact with inner window directly. One of the commands I can do to inner window is paint a box. There is one other library to go with curses, which is panels. Again, this is all semantic. All this is doing is it provides a little bit of it does a little bit of arithmetic for us. So rather than us having to manually calculate the where to put text inside this, we just say add a string to the upper left-hand corner of inner window, and then Cursus just internally adds 6 and 10 to get that string to the right location. The panel deals with updates, so that windows, we have ideas of windows going on top of each other and covering up text underneath. That's what panels does, is it does the grunt work in figuring out what needs to be hidden. So you associate a panel with one of these windows that you create, and then nothing updates automatically, so you have to say update all the panels, and then you have to tell Cursus to do a drawing update. And then here I'm just getting a character. Once I get the character, then the function ends. Function ends, my wrapper finishes, it cleans up, and I fall out. Let's try that. The minute I hit a character, remember, I don't I don't type in a bunch of stuff and hit enter. The minute I hit a character, the program interprets it. So I should be able to do something like my inner window. Let's see. Oops. Inner window dot add string. So I said start at 1, 1. Actually, these windows do start at 0, 0. When I say draw a box, the box does not go outside the window. It goes inside the window. So 0, 0 of my window is actually this little angle upper left-hand corner character here. So I had to go 1, 1 to actually print this inside. And this one is almost identical to the one we were just looking at. I think what I added to it was here, I just showed a couple other commands. I can get the XY coordinates of the inner window, and then I use a little, at location 1, 1, here's that famous C-style printf formatting that you have in Python. So I create a formatted string. Let's see what that does. So what I'll do is I will take my compiled C version. I'll make sure that it compiles and runs fine in Vagrant, which probably means it'll run fine in just about anything. And then I'll post that. I'll post it in the daily diatribe. So what you can do is have a running editor that you can experiment with and see how it works and compare it to what you're trying to do. So this shows the workflow. This basically talks about everything I've talked about. Resources. These are nice resources to get up to speed on the curses commands that I didn't necessarily talk about. All right, so that's the final project. Of course, I'll check Piazza for any questions I haven't answered in the last several hours, and of course I'll be sitting here to help you finish up if you got something going on 4 or 5, and then of course as you move forward into part 1 of 6. All right, okay.